Hi everybody, this is Shiva Bira. Welcome to my channel. In this session I am going to explain you how to use 555 timer in different modes of operation. Not only that, we are going to learn what is meant by a timer and the pin diagram of 555 IC, the construction and also the applications. So timer means it is a signal which is going to have both on state and off state, and because of this the output of a particular system is going to be changed. Simply it is a signal. So it is going to provide periodic signals to a digital system which changes the state. And different modes of operation of 555 IC timer, as we have discussed, Astable mode. Astable, the name itself is going to tell us it doesn't have any stable output states. Irrespective of the triggering input, the output will be there for this mode. And monostable, in this particular one, output state will be stable and the other will be unstable. And when this stable output is set to high, the timer is going to enter its high state. And the last one is bistable mode. Here both the output states will be stable, and at each interrupt the output changes from low to high until it receives an interruption. So till that it retains in the same state and it continues, it goes on. If you go for the block diagram of 555 IC timer, it will be available in two configurations. One is the metal package. So here we are going to have like a circular disc shape, and another one is like a DIP, dual in package type. Basically it is an 8-pin IC. Let me brief you the terminals here. So 1, 2, 3, 4, 5, 6, 7 and 8. The first one is ground, second one is trigger, third one will be output, fourth one. In both the configurations the pins are going to represent the same. Fifth one will be the control voltage, sixth one will be the threshold, seventh one will be the discharge, and last one will be the sub VCC plus. Here somewhat the description about each pin. Ground reference, first one. Second one is to give external trigger voltage. So this is the output voltage, which is 1.7 volts below plus VCC or to ground, and to reset the timing interval. Control voltage, so here it provides the control access to the internal voltage divider. Generally a potentiometer can be used as this control to control the voltage. And the threshold voltage, and this is the discharge, this will be in phase with the output, and VCC is the positive voltage supply. So these are the description of the terminals that we use in this particular timer circuit. Basically the name of this is the circuit diagram which is going to represent the 555 IC timer. Here, as you can see from this circuit, we use 3 5K resistances to have the voltages of the threshold voltage for this comparator, and also for lower comparator, I mean that is comparator B. That is the reason why this timer is considered as a 555. Let us suppose here we are going to use 9 volts of supply, for example. Let us consider, and this point the threshold will be at 2/3 of this VCC, because the voltage will be divided equally across each resistance. So here we are going to have 2/3 of VCC, means 6 volts, and at this point we are going to have 1/3 of VCC, that is 3 volts. So this is at 6 volts and this is at 3 volts. And as you know that comparator means this will be the output of this particular configuration depends upon the difference of these two voltage levels. Say for example, if the trigger input is, as we can see here, the trigger input is connected to the inverting terminal, and we know that this point is we have considered that this point is at plus 3 volts, and if you say if the trigger voltage is less than this 3 volts, the output of this comparator will be from low state to high state, means it is going to have set in this particular flip-flop. So the set bit is going to be in high state, so that the output of the flip-flop is going to be high. And similarly, when the threshold voltage it is more than 6 volts, already we have set this point to 6 volts, and when this control voltage becomes more than 6 volts, the output of this flip-flop is going to be low, and R is going to be low state, and the output is going to high. Similarly, the converse is going to happen. When S is equal to 0 and R is equal to 1, the output is going to have 0 state. Like that, depending upon the inputs of flip-flop, or you can say the output from these two comparators, the state of Q is going to be either 0 or 1. So that is nothing but a signal. So 1 for some time and 0 for some time, and the duration for which it remains in on state or off state, that depends upon the trigger voltage and these control voltages. So that's how this timer is going to work. Now here let me brief you how these discharging and reset of the transistors T1 and T2 are going to work for us. Here the transistor T2 acts like a buffer, and it isolates the reset terminal. So whatever terminal it is being it has been connected here, that is fourth terminal, reset terminal, it is going to isolate the reset terminal from the flip-flop and also the T1. That is the purpose of this transistor T2. And when T1 goes low, when T1 is off, the capacitor is whatever capacitor is connected at this particular terminal, it is going to be charged. And when T1 is switched on, and it is going to be connected to the ground directly, and the capacitor will be discharging. So the charging of capacitor and discharging of capacitor depends upon the signal which is received by this transistor T1. So let me show you the diagram here. You can see here, this is the charging of the capacitor up to 2/3 of VCC. Again, once it reaches this threshold level, again it comes to the discharging mode. Means during this period T1 will be off, and during this period T1 will be off, yes, and during this period T1 will be on, and it continues T1 on, T1 off, like that. And when T1 is off, we are going to have the high state of the output voltage, and during this period the low state of output voltage, like that, high state and low state. The duration of this high state and low state is going to be decided by the trigger and the control voltages. That's how we are able to generate one signal. That's about the 555 IC timer. So please do subscribe to my channel. That's all for today's session. Like, share your views, and give your valuable feedback. Thank you for watching. This is the Shiva signing off.